Hello and welcome back to episode 2. We're going to continue with the power supply theme, and I've printed another case, and this one's going to be for the 1581, and it'll also power 1541 too as well. So I've taken the same overall model and just modified it to take two separate switching supplies. There's no AC component to this one. So I've used the same back plate for airflow. I've modified the lid slightly so that I've got these two parts here that actually engage with the two power supplies and hold it all together just by using the 4 bolts through the bottom. Here's our front plate, and we've got the similar aviation style connector, 6 pins, but it's smaller and it doesn't need to carry as much current, so that's really not going to be a problem. We're only going to be using 3 of these pins anyway. We've got 2 cutouts for those meters from the last video and an IEC port. Now once this is together, I've just used some M3 cap head bolts. They'll go through there and leave around about 10mm to interface to the top. Now some people use brass inserts in their 3D prints. I don't think they're any stronger, to be honest with you, because they just pull out. So if you're going to strip them either way. If you're careful, then you can just make the holes the right diameter, which for M3 I've found, and my printer's pretty much dimensionally accurate, a diameter of 2.8mm, and as this goes together it will cut a thread. So as long as you don't spin it and strip the tits out of it, it's going to hold it tight. With 10mm of thread there, I don't think that's going to be any kind of issue. But if it is, there's absolutely no problem just taking a small drill and then melting in some brass inserts into the top. Either way works just as well. So in the bottom, we've just literally got our captive slots here to hold the power supplies in place. Got a few defects through the PSU there, but like it was only cheap filament, so yeah, I expected something to go wrong. That's pretty much it for these parts. There's nothing really to surprise anyone here. It's just like the other one. Unfortunately, I've got another 2 of these garbage fucking meters, and yeah, let's just, I kind of glossed over this in the last one because frankly it gave me the ump and I turned the fucker off. What happens here is if you only connect the voltage sensing, which are the thin 3 wires, you've got no problem. It reads voltage happily and fairly accurately once you trim it. However, once you connect up the thicker wires for the current, it determines the voltage by assessing the drop across the internal resistor. There's a little bit of a problem with that because it doesn't do it properly, and it's too close to its operating voltage to actually display anything properly. So it just seems to clamp to a silly voltage and it doesn't work properly. I'm hoping that with this build we're going to have the 5 volt and the 12 volts, and that, you know, it should work better. Now I've made other types of power supplies for other pieces of equipment before along a similar line to this. I've made is a 5 volt one that's a lot smaller, and I made this just as a 5 volt power supply. This meter here tends to work a bit better for some reason. It's one of the red and blue rather than blue and blue meters. It looks fairly similar, but yeah, how strange is that? And it's wired exactly the same, but as you can see it's just a little 5 volt 3 amp supply that I've got shoehorned in there. The top holds it together, and just 4 bolts, job's a good one. I haven't put this one together yet. It's still, you can see the IEC still not bolted in. The other thing we use is these little square rubber feet. That they're really quite good. You just peel them off, stick them on. You need something because this PSU is so slippery that you need something to stop it sliding all over the place. But yeah, what I'll do is I'll make the connections to the front plate, and once, I'm still waiting for one of the power supplies to turn up. Once it turns up, we can revisit this in this same video, and I'll record that segment and we'll build it up. If I move this to one side, here we're going to show the schematic for this power supply. It's going to be much simpler than the last one. We're going to say that, start this side, I think. If this is our IEC, we're going to come in there, there and there. We're going to say that the switch is going to go straight through. That's going to be earth. That'll be live and neutral. Live and neutral. There we go. So the live will come through the fuse. It will go back round to there and then come out there. So we're going to have neutral, live and earth. For our two power supplies, we're going to say we've got 12 volts, 5 volts, and we're going to literally come into each one with just a Y connector. I'm going to actually cut the ends off this IEC and just solder 2 wires to each one, or crimp, whichever. So this will be live. Neutral will go straight over to here. That'll be neutral. It'll come down there. This one will be neutral. We joined. Same with earth. Nothing funky there. We know full well that these supplies got over voltage and bloody pen's leaking. Over voltage and over current protection, so I'm happy just having the fuse in the IEC. That's going to be plenty enough. Now on the output side, we've got 2 of those meters. So for the current, we're going to come out with the negative, or the minus side. Let's call that 0. Don't want negative on there. 0 volts DC. And that's going to go and get joined together and it's going to come out to one of the 3 pins, and we're going to say it's going to go into that one there. So that's going to be our 0, and that will allow us to measure the current. Now the positive for each meter, so for the 12 volts, it's going to come out, go straight to there, and then we're going to come out of the meter with the red and yellow. Again, the black's not connected, and this will be plus 12 volts DC. And for the other side, we're going to come around this way. What a rubbish drawing. So we're going to say this is 5 volts DC plus 5 DC, and we're going to come out with, jump over that, jump over that. Again, that's going to be the red and yellow thin wires, and that's going to be the whole thing. Right, here we are back again, and after the first video it occurred to me that I had a couple of high powered resistors that I used to recalibrate the 12 and 5 volt lines on Atari ST power supplies after I recapped them. So with that, I thought I could show you exactly what was going on without using the electronic load. And the electronic loads, they're brilliant for actually setting up a power supply, but they do kick out a fair bit of crap, which, well, you'll see on the scope, there's a lot less of when I'm just using a resistor. So what we've got is the piece of shit AliExpress £3 special that we had in the first one. We've just got a scope, and I've got 12 volt written on this, but it's a 10 ohm resistor. So Ohm's law says that current is equal to voltage divided by resistance. So we're going to measure the 5 volt side, we're going to divide it by 10, and we're going to pull half an amp. Now the problem here is this fucker is going to get fucking hot fucking quick, because it's going to dissipate everything as heat. It ain't got anywhere else to go. Now as we can see on the scope at the moment, we've got a little bit of crap, much less than with the electronic load connected, and that's because it's going to pick up a little bit through the scope probes. That's, you know, not a lot I can do about that. But once we turn on this AliExpress special and we pull some current, we're going to see something a lot different than what we had before. Basically, we're not looking through all the shit that was going on from the electronic load. So there you can see the baseline that we've got at the moment. Let me just turn this fucker on and you'll see what I mean. One thing to note is, because we're dumping it all as heat, I can't run this very long because it's going to get fucking hot. So let's just power this up, and I'll turn it straight on at the mains. Holy fucking shit. There you go. That is purely how bad this piece of shit power supply is. It's fucking everywhere. Let me turn that off before something starts glowing or cooking or both. There we go. Oh, it's not too bad. It's not too bad. It's just a little bit warm. So that's at half an amp. Now, let's take this off. And let's kick this party up a notch. So here, I've got a 2.2 resistor. Now 5 divided by 2.2 means we're going to be pulling 2¼ amps. Now this power supply is rated at 2.5. This is going to get much quicker, much faster. So let's see how shit this is going to be. Well, fuck me. That's just how bad this is. Look at that. Shit everywhere. So I'll shut that down, because now we're dumping. Oh, it's not too bad. So let's get another look at that. Holy fucking shit. That power supply has just lost its tits. There's nothing else in the circuit. You can see that's just absolutely fucking diabolical. So with these load resistors, you're getting a pretty good example of what is coming just out of the power supply. Alright, warning. We've got mains voltage here, so if you end up blowing your arsehole out, the cat, the dog, your missus, your house, or God forbid your Commodore, that shit's on you. Okay? Cool. Well, here we are back for the build. Here we've got a faceplate that I've mostly assembled. The IEC isn't fixed in yet. I've put the 2 rubbish meters in and the aviation connector. On the back side, if we take the IEC first, all I've done here is I've spliced each wire into 2. And I used a wire stripper and just stripped back the insulation slightly, just so I could wrap the other one round, soldered it, and then I put some heat shrink over it. So we've got live, neutral and earth with 2 tails on each one. Nothing funky there. For the 2 meters, I've tied together the returns from the current side, and they go to the negative, because on this power supply both the negatives are joined together. So there's 2 positives, a 5 volt, a 12 volt and a common neg. So we've got our 2 negatives going to the meters, we've got our positives going to the meters, and that's it. So really we've got 6-10 wires to hook up. I put some ferrules on the end. They're yeah, just to tidy up the wiring. I may actually change them to fork crimps, but we'll see yet. As you can see here, I've put heat shrink over each terminal, so it just, you know, ties it up and stops any shorts that you might get. So let's have a look at what we're going to do. So we've got another two Meanwell power supplies. These are tiny, look at these, absolutely tiny. We've got a 12 volt and a 5 volt. Now the 12 volts at 1.3 amps, we only need half an amp, so at least we're not wringing the tits out of this one. So you know, we should have good regulation. On this one, it's a 3 amp supply. We're only pulling 1 amp. I mean, these should both run nice and cool, and we're not stressing them, so we're not going to be really pulling the voltage down. So it's all good. So let's get this hooked up. So what I'm going to do is I'm going to put the 5 volts on the left, 12 volts on the right, just so I know what's going on. So this is our 5 volt one. It's a RS15-5, and what we're going to do is it just presses in here, and just, I 3D printed this so that it could take them exactly, as you can see here. And then when the top's on, there's the two things in the top that will just hold them in position. So we only need the 4 screws to hold it all together. I know it looks like there's a lot of room in there, and there is, but there you go. It's better to have a lot of room than not enough. So let's go with, let's start with the earth, shall we? That's a nice easy one. So all we're going to do is we're just going to go in through the top, like so, and then crimp down on that. And we'll go over to the top of this one. They're going to be jumping around all over the place until we get all the wires in, so I wouldn't worry about that at the moment. So here we go. Some of these crimps may be a bit big for the terminals. Might have it, oh, there we go. Might have to rotate it slightly to get it in and tighten it up. So that's the earth done. We've got the positive next, which is the live and the neutral. So let's go with the neutral as it's next to the earth. Nice and easy. Just drop that terminal in there. Screw it down. Look at that. Jobs are good. And same this side. There we go. A big wire, so we'll just have to make sure that's in there okay. Happy days. And now we're going to go with the live side. We're fused at the IEC blocks. I'm really not concerned with additional protection there. Anything happens, you've got the IEC fuse and you've got the fuse and the kettle lead, so it's not going to do a lot. Right, and just like that, that's our power for both of them. Super simple. Now, for our negative side of each supply, I thought for the meters we'll have 5 volts at the top, 12 at the bottom. Now it's important that you get the right way around. You don't want to be returning one to the other. So for 5 volts, we're going to take this and we're going to go to negative, just like that, V negative. And the red lead is V positive. There we go. Super simple, this one. And then this black lead goes on V negative, and this white lead is the last one, V positive. Just like with the 64 power supply, it's all printed out of PETG. I prefer PETG over PLA because it's got a bit more flexibility to it before it cracks, and it can take more heat. PLA starts to get a bit wobbly, you know, 50-60 degrees. I know you're not going to get anywhere near that, but it's just a little margin. You could print in PLA and it should probably be alright, but why take the risk? There's no real cost difference. Okay, so they just both slip in there. The front slips in there like so. And we're ready to power this up. So, I've got a kettle lead here. Let's plug that in. What's the worst that can happen? Well, not that, clearly. Right. Let's actually turn the kettle lead on, that might help. Let's try this one then. And look at that, we've got 5 volts and 12 volts straight away. Not these meters matter of fuck, because as I said in the first video, the 5 volts seems to be so close to the operating voltage of the meter itself that whilst you're drawing current as well, it seems to not like it and just float all over the place. If you use the meter just for voltage and you don't hook up the current sense, it works perfectly. And it can get down to quite a low voltage before it, you know, disappears. So, but at the end of the day, really, what do we expect for sort of £3? You know, it's £2.50, £3. Yeah, you know, it is garbage, but it's cheap garbage, and we've bought it because it's cheap. So, yeah, at the end of the day, I suppose you get what you pay for, don't you? Okay, right. So what we need to do now, just put it in there like that. The 5 volt stays on longer before it disappears because it's got more supply before it uses the energy. What we're going to do now is hook up the cable, and we need to do some calibration on it to get the right voltage, set the current up properly before we even run it. So here we can see I've made a cable up, and I've used a 3-core 0.34 square millimeter cable. It's got three cores in it, and I've hooked up the 3 and made a, you know, a 1581 1541 2 power connector on the end. So this is all ready to go. This cable can take 4.5 amps, and we're not even through each conductor, and we're not even close to that. It was actually an offcut from a sensor cable, from the industrial sensor cable. So, waste not, want not. Right, so we're back again. As you can see, we've got the meter hooked up, the load hooked up, and yeah. So the first thing we're going to do is start with the 5 volts, and we're going to calibrate the current. So let's swap that in there, turn that on. There we go. So it says 5.10 volts, 5 volts on the meter, and the fluke, which I'm going to trust more, is 5.03. So it's a 3 amp supply. Let's bring this fucker up a bit. We might as well go large. Get close to 3 amps. And the reason why we're going to do that is, like I said in the first video, we need to then set it at the highest amount, so that is your window. As you shrink your window, the error shrinks with, oh Jesus, it's 2.99. Look at that. Well, look at that. Superb. The fluke and the load say 4.3, 4.4 volts. Yeah, the meter's well, the meter's clearly lying in it. Let's see if we've got any adjustment there. Yeah, the meter is pulling the same shit as the other one, and that's, yeah, not really to be surprised, is it? Let's turn this back down. We're going to go down 5.04 volts. We might as well tune it for that. Yeah, let's just do that so we don't kill anything. Alright, I'm going to set that back so it's right at a lower amount. There we go. Let's go back up the scale. 1.22, 1.32. Oh, well over there. So easy to ring this one up. 3 amps, that says 3.05. Let me just tune that back down. I'll take that down to 3 amps. There we go. Now if I take this back down, that is close enough. Now on the voltage side, we've got 5.02, so I'm just going to adjust this one. .02. Let's see if I can get it to track fluke. No. 2. 2.90 amps. So it says 4.97 volts there, and we're at 4.38. Yeah, I think it's not taking into account some other stuff, I think, as well. See, the other thing we've got is, as well as what I said earlier, we've got a voltage drop through the cable. I think these work just by calculating the voltage drop across the shunt resistor, which is on board, so never mind, it's no big deal. It's, when you think about this and it's all said and done, the most important thing is the current rather than the voltage, so you can see what you're pulling. It's just an indicator otherwise. So let's power this down. There we go. I just want to turn off the load a second. I apologise for the background noise. It's I've got a fan going next to me, that's better. It's majorly hot in here. Okay. Let's switch this over to the 12 volt side, which is this side. There we go. Nice. Right. Next thing we're going to do is repower up the load. Turn on the 12 volts, and it says 12.1, and we got 12 volts exactly on the fluke, nearly. Exactly nearly. What kind of grammar is that? Okay, let's give this some Ned Ted. We can only go up to 1.2 amps with this one, so let me just .3 amp. Whoa, a bit over there. 1.21. Let's back it off slightly. 1.2. See if we can get it to. There we go, and that says 1.18. That's not actually not bad. Let's just trim that down a bit to get our full range. Come on, get on there. Don't want to be slipping and short the rest out. we go. That's 1.19, 1.20. Come on. Yeah, 1.20, there we go. And then what we're going to do is we're going to dial that one back. And that is good enough. 12 volts, lovely jubbly. And that's all there is to it. I'm going to leave that at 12. That's close enough. Yeah. Let's shut that down. 5 volts will take a few seconds to go off. Right, so I apologise for the fan going. Right, so all I've got to do now is reassemble the power supply. Take this off the front there. So this is just designed to sit in there. It'll get a lot more rigid once the front's on because it sits in a groove in here, both sides. So you can press on it and it won't move. These just fit in place like that. And then that one goes in that end for the airflow. If there's enough interest, I may make the design files available and a step-by-step guide. It's really super simple. So once it goes together, it does look the part. You see these parts here engage with the top of the power supplies, and they allow the air to still come out the vents. So it's really not bad. Like I said, you just drop these in. Now when I'm using bolts with plastic, I tend to put some pressure on them as I'm doing them up. So we've got our power supply like this. Let's take an Allen, hold it down and give it some pressure as I'm pushing down, and then you'll feel it bite in. There you go, it's squeaking now. So you know it's cutting a thread as it goes. Now when you're doing it up, you've just got to be sure that you don't strip it. So when you feel some resistance, that is literally when you stop. Like there. And we'll do the same over here. I mean, you might be tempted to use a electric driver like a little Bosch XO or something like that. You know, something like that. But don't. Just don't even think about it. Because you will just strip the threads right out of it. And then it'll be ruined, and you'll have to put metal inserts in at that point. They'll just rip the arsehole right out. There we go. Same thing again. It does get a little bit stiff, but you'll feel the resistance change when it gets to the end of its travel. Yeah, and it'll start squeaking. Like I said in the first video, 2.8 diameter for an M3 bolt is what I cut into. So I have 3.6 as clearance for the bottom half, and in the top half is 2.8. There we go. Last one. Now, in the time between these two videos, I've been testing the first supply for the C64, and that's been working fine. No issue at all. Might have an issue with a junker, but power supply has been fine. So, like I said, I bought these sticky pads. And literally just, as you might imagine, PET is really quite slippery, so you want something on the bottom. These come off eBay, they're not very dear. Just like that. As you can see there, it's actually solid. Because they engage with the power supplies, that's not going anywhere. That's completely solid through. And the front's also solid when you try and push in. I know it looked a bit wobbly earlier, but that's because once it's in situ, it's got all the strength behind it. And there it is. What I want to do is, I want to try this without Jiffy, just to see how much voltage it pulls, or current it pulls on the 12 volt line. So if I fire up the 128, there we go, without Jiffy. Turn on the drive, set the disc. There we go. No problem. Now, here we go. Right now we're pulling bugger all. So the 128 is pulling, well, 1.83 amps, and like I said, that's just got an arm SID in it, so nominally it's going to be about that. The 1581 is pulling under half an amp on the 5 volt line, and absolutely fuck all on the 12. So let's see what happens. So it's now loading, and it's pulling like less than 100 milliamps on the 12 volt line, 50 milliamps. On the 5 volts, it's up to almost 600 milliamps. That's 570 milliamps, which is, it's just fuck all. We've got 3 amp capacity on the 5 volt, 1.3 amps on the 12 volts. These are not even going to be taxed at all. And on the 64 supply, we've got 10 amps in there, so holy shit. Right. Let it decompress. Oh, we've got to wait for the little men to run on. There we go. Yeah, the highest I've seen the 12 volt line go is 70 milliamps. What's it doing there? I'm still loading. And there we are. It's in. Right. I've got my hands on the 1541 too. And using the same power supply, let's fire this fucker up and see what happens. So we're going to go into Jiffy. My 1541's got Jiffy on it as well, so let's power that up. If we go, keep forgetting Jiffy commands, there we go. So here we've got Combat School on disc. Look at that. Okay. Right, so if we go like that, let's see what this drive pulls out of it. Oh, that's a bit more interesting. So the 5 volt line is not as high, it's only at 400 milliamps. The 12 volts though is shot up to 350. Well, that sounds healthy. Oh, bollocks. Right, so despite having Jiffy, it looks like it's got its own fast loader. So it may not be as fast. How about that? Oh, there we go, we've got something. That's yeah, so here we go. It's still loading. It's a non-jiffy load, so God knows how long this will take. Yeah, 5 volts is 400 milliamps, 12 volts 350. That's it's still not bad, and it's still well within what the power supply is spec'd for. And this is going to be kind of a worst case scenario because, you know, it's a bigger drive mechanism, and yeah, it's going to pull more, isn't it? It's just a bit more of a beast, just like this fucking game. Jesus Christ, how long is this going to fucking take? You get so used to using cartridges and stuff that yeah, you got to load it off real media and you think, what the fuck's going on here? Right, anyway, my power supplies look absolutely superb, and that's what I'm gonna use going forward now. As I said earlier on in the video, it can power multiple 8-bit machines. Oh, it's in, look at that. So let's wrap this up then. Check out 8-bit Retro Refix. He's got some good stuff going on over there. Thanks for watching.